Hi, welcome everybody. Today we're working on using a lever. This is based on the lab in Unit 6, Lesson 7, pages 263 through 267 in your student pages. We're going to tweak it a little bit. Today we're mostly going to show you what mechanical advantage is and how it works to help us out, and not really do so much of the math today. We'll get into that a little bit later on. All right, so mechanical advantage. We haven't really talked about it yet. We're going to talk about it a little bit today. What is it? All right, well, mechanical advantage is kind of like this magical little force that allows us to do more work with less effort. All right, it gives us an advantage. It gives us help in order to lift heavier things that we would normally not be able to do. So sort of like superhuman strength without the ability to fly. So it allows us, by using simple machines and compound machines, to set up a way where we can lift more weight than we normally would be able to do, hit things farther than we'll normally be able to do, and other activities like that. I'm going to show you a couple real-world examples in a little bit, and then for me, from my class, we're going to have a little extra credit sort of thing that you can, if you can find me a real-world example of this, we can maybe get you some points here. So first things first, we're going to talk about just regular mechanical advantage. I have a bottle of water here. I'm going to back up just a slight bit. And then I have my, you'll have this in your activities lab packet. It is a force meter. Basically, it tells you how many newtons of force you need to lift up an object or pull on an object. So what I'm doing right here, I'm attaching a rubber band to the bottom of the force meter so I can pull up this bottle of water. Okay, and you can see I've lifted it up. Obviously, it's not pulling. I can read it here. Takes me to lift this bottle of water. It's not completely filled, about 3/4 or so. It takes me 4 newtons of force just to lift it up. All right, so we're going to take this information and we're going to move over here, and we're going to use a lever and show you how the differences are. I know you're flying, so this is kind of even more superhuman. You get to fly a little bit because I get to move the material. All right, so what we have here, this is what it's set up in your book, the same way it's set up in your book. I have my force meter here, and I'll have my water on this side, and I'm going to put the water at 7.5 millimeters. And what I've done is I've already actually marked it on the paper, so you can't see that, but I've already done it to make it a little bit easier for me, so that when I'm moving this stuff around, I don't have to recalculate it every time. So this is 7.5 centimeters away from the center of the fulcrum. Remember, our fulcrum is right here at the pencil. That's the fulcrum of this. So what I'm going to do, I'm not going to let this go, but I'm going to pull down this force real hard to lift this. All right? And you can see that the force meter is really close to the fulcrum, so I'm not getting a whole lot of mechanical advantage. And when I pull down on this, it takes me 8 newtons of force to pull down to make this parallel. Okay? Now, what I'm going to show you here after I break it is... This is a temperamental type machine, but we'll fix it. What I'm going to do now is I'm going to move my force meter here down to about 5 centimeters away from the fulcrum to give me more of an advantage of lifting this water bottle. And let's put this in the center again. And this time you'll see as I pull it down, now I'm farther away from the fulcrum, and as I pull down, now I only need about 5 newtons of force to get it to parallel, okay? And again, I'll break it. All good. We'll figure it all out. This thing can be a little temperamental, and that's all right. This isn't the greatest setup in the world, so this is why we thought to change it a little bit. It's a little bit difficult to get moving and keep intact. It tends to break down a lot, as you're seeing, because of the weight of the materials and stuff like that. So, all right, now we're going to move this fulcrum all the way down. I'm going to move it all the way down here to about 10 centimeters away. from the fulcrum. So my force that I'm going to be pulling on is 10 centimeters away from the fulcrum. And we're going to see how much force it takes me this time with a lever to bring it to parallel as I put this back together. And this time, to get it to parallel, it's only taken me 2 newtons of force. All right, so when I was close to the fulcrum here, at only 2.5 centimeters away, it was taking me 8 newtons of force, 7.5, 8 newtons of force to make it parallel. As I moved it out to about 5 centimeters or so, it took me about 4 newtons of force. And now as I move it all the way out here, it's only taken me 2 newtons of force. Let me see if I can pull it out even farther to about 12.5 centimeters away from the fulcrum. And this time, so you can see what's happening to my lever. The lever length away from the fulcrum, this length is increasing. So my distance is increasing, making work easier. Remember, we've talked about that in the class, that as we increase the length of a lever, we decrease the amount of force that we need to do the work. Okay? So as I pull down on this, I only need 1 newton of force to hold this bottle up at parallel. Whereas all the way over here, I needed 8 newtons of force. 8 newtons, 1 newton. 8 newtons, 1 newton. As I lengthen my lever, as I make the lever longer, my work is made easier. I don't need as much force. And that's the purpose of simple machines, and that's what we're trying to get across to you. I'm going to put this down here. Okay? That's the purpose that we're trying to get across to you. So the increase in distance makes work a little easier. Now, where do we see this in real life activities? Well, I'm going to show you a couple. Come on. Another ride for you. Right here you can see I have my own little weight bench. I don't know if you can see it real well. But right there you got my own little weight bench, and it's set up, and it has its bench machine, and it has other things that are just for regular lifting. But if I move closer, I can find that right down here on the bottom, I have a pulley system. I have my wheel, I have my axle, wheel and axle, and I have a pulley system where the rope is attached. And if you can see it, I'll try and kind of go across. You can see the cable going all the way up here. And it goes down again and up again, and then it goes all the way across over to the front. Okay? And again, what that's doing, it's increasing the length, or increasing the distance that the force, through which the force is applied, making me able, or allowing me to lift heavier objects with less force. All right? I'm still getting a workout in, but what it does is it makes things a little safer for the person doing the work, because it's taken across all sorts of distance, and you can see I'm just doing this with one hand, and I'm able to lift something. I'm not putting a whole lot of weight on there, but because the distance is so much greater on the cable, it allows me to do more work with less force. All right, over time, I'm still doing the same amount of work, but the force isn't there, so it's a little bit safer for people, especially just getting into working out. A lot of people your age who are just starting maybe to get into exercising. It's very good to have a safety system, and pulleys and cables will do that to you. So you could see, even from here, you got the pulley system, you got a very long cable, and that extended distance allows me to do more work with less force. I know I keep hammering that in there, but that's what it is. Well, what about some other examples? Well, I got 2 things over here that I'm going to show you in a second, and it has to do with sports, okay? And the way I look at it is we can talk about 2 sports that I'm very familiar with, which is baseball and golf. All right, so right here I have a baseball bat, okay? And what a baseball bat does is it acts like a lever, okay? The pivot point, or the fulcrum, is my wrists, and as I swing through, my wrists snap, and I get more force through this extended distance to hit the ball. Now, when I was younger and we didn't have places to baseball bats, or it was only a whole lot of people, wasn't a lot of people to play a full game of baseball with, we used to go to a tennis court, and with a racquetball or tennis ball, we played baseball with our hand. All right? So somebody would pitch it in, and we'd come in and swing with our hand, open hand, and try and hit the ball. Well, one thing you'll notice right off the bat, you don't hit it as far. Even with the tennis ball or a racquetball, you don't hit it as far. All right? Can you imagine somebody in the major leagues like Albert Pujols trying to hit a baseball with his hand? It's not going to hit a whole lot of home runs. All right? You're not going to hit a whole lot of home runs. So the bat was introduced, obviously, for safety reasons, and they didn't want to break their hands, but the distance of the bat, the length of the bat, increases the force output. The output, here's your input force, is your body. Output force goes through the bat, the distance, and you can get more force to do work, which will allow you to hit more home runs. Okay? So that's what a bat is for. So it's a lever that increases distance of your arms to give you more force. Now, this is a golf club, and I'm going to show you one thing. I just have my finger here, and I'm holding this up. Okay? This would be my fulcrum for my golf club. Okay? You can see you're very balanced, but what do you notice? The distance from here to the head of the club, where the most mass is much shorter than from my fulcrum to the end, which is here. I mean, this distance is much greater, right? Okay, so what we've done here, again, we take the mass, we put it on one end, and we keep the length, and we extend the length to about 43, 44 inches here from the head to give you more club head speed and therefore more power with less force. I can swing this club, with say about 100 mile per hour swing, and I'm going to get a certain amount of force behind it to get the ball out there 250, 300 yards. Right? I average about 265 or so. Okay, so I can use this length and force to get the ball out there. Now, I'm not going to hit a ball with my hand or throw a ball with my hand 265 yards. It's not going to happen. So in order for me to increase the force necessary, give me a mechanical advantage, I need something like a club, like a driver, that's balanced and extended 45 inches to give me that leverage to hit the ball out. Again, this is another lever that we use that extends it. Again, the fulcrum of the club is here, but you can also look at my wrist as a fulcrum as they snap through and allow me to hit the ball that much farther. So those are two examples in sports, or three examples, because if we talk about the weight machine, those are three examples in sports that give us a mechanical advantage to either lift something heavier, in the case of the pulleys and cables, allows us to lift something heavier with the increased distance of the cables, or to hit something farther with the increased distance of the lever. All right, the lever is longer, so we can hit the ball farther with less force. It'll still do still do the work and get out there. We just don't have to put as much input force into it. Okay? So I hope you understand what mechanical advantage is. The golf clubs, the pulley system on the weights, the baseball bat, they give me a mechanical advantage to hit something farther or lift something heavier, to do more work that sometimes seems supernatural. I know, especially if you watch some of these baseball players, you might think that, the way they hit the ball, or some of these golfers. Tiger Woods hits the ball, 300 yards. I think Rory McIlroy probably hits it even longer. So it gives them that mechanical advantage. They couldn't do that with their own bodies. So we use simple machines to gain a mechanical advantage to do things better or easier. Okay? I hope you enjoyed this. Again, from my class, and your teachers can set this up. If you can send me in K-Mail example from sports, from your activities, anything that you can think of that will help you personally gain a mechanical advantage. And I'm not talking about snow blowers. I'm talking simple machines here. All right? Not gas-powered machines. We're talking simple machines. If you can figure out something and explain how you gain a mechanical advantage, I can give you, 5, 10 extra bonus points. That'll help you out. All right? But you have to explain how it gives you a mechanical advantage in what you do. I hope you enjoyed this one. I did like this one. I thought when we simplified it, it worked out a lot better. Enjoy the day and gain your mechanical advantages where you can. Take care.